Okay, you're all set.
Awesome.
Thanks.
Thank you. Yeah, thanks for tuning in. I'm Keval Shah. I am currently a software engineer at Splunk, and I'm also a graduate of CU, the 2020 batch. I was at the Master of Science Computer Science program, and since then, since 2020, I've been employed at Splunk as a software engineer on the observability team, which is like a fancy word for monitoring solutions, right? So, first of all, thank you for inviting me to this talk. And today, I'll be talking about distributed systems and cloud computing topics, pertaining to the situation of early career interviews and how the industry scenario has changed recently over the last couple of years, and how distributed systems and cloud computing topics are affecting interviews, and what are employers now expecting, how are their expectations shaping into changing the interview process and so on, right? So I chose this topic because from my recent experience, I noticed that there was a small gap that was being generated, where the candidates, especially those in the early stage of their career, were not very up to speed on, or were just not prioritizing their cloud computing knowledge and in general distributed systems knowledge, right? So yeah, let me move one step ahead on that. And so let me first define a clear separation between distributed systems and cloud computing in in respect to this presentation or the talk that I'm giving, right? So distributed systems is a pretty abstract term. You can apply it at a super low level in terms of systems, and you can also apply it at a very high level in terms of cloud computing. So and what do I mean by cloud computing, right? So let's in the perspective of this talk, let's consider distributed systems as the core concept of having connected computers, systems, and then let's call cloud computing as using that particular topic as a very good example of providing services over the internet, right? So in layman terms or in real world use cases, cloud computing would be watching, a movie on Netflix versus watching it offline on a CD, right? So this is essentially being powered through the concepts and applications of distributed systems. Better examples are using Apple Pay versus paying in cash, making PowerPoint or Google Docs instead of just making it offline on your machine, right? So these are all the real world use cases that are powered by cloud computing per se, right? So now this is just a very high level 10,000 feet explanation of what I mean to say by cloud computing products and services. And now, the immediate question that comes to your mind is that, but how is this related to big tech employment in interviews, right? Yeah, so what if Netflix is streaming data directly over the internet onto my TV? What if Apple Pay is doing it over the internet, and I'm interacting with multiple systems? How does this feature set and this evolve into my employment or my opportunity, internship opportunity, or of my first job opportunity at a big tech company, or let's say even a tech startup, right? So in today's scenario, every big company or every company that is in tech and also not in tech, right? So for example, restaurants as well, right? They have a digital presence, and with that digital presence comes the burden of deploying your infrastructure and making your services available to everyone, to the customers globally through internet, right? So this is where the concept of cloud becomes, applicable to almost every other company out there which has a technical presence. And down the line is the cloud computing phenomenon is powering your employees' bread and butter services or products that they are selling to make money in the end, right? So as software engineers or as even ML engineers or even managers or any person in technical role is expected to work on cloud directly or even indirectly, right? So in the end, I can conclude by saying that it becomes very common for engineers and scientists to build systems for the cloud on a daily basis, right? Even if you are a ML engineer, even if you are building models, with great accuracy and with minimal bias, in the end, you would want that model to get deployed and be accessible by the world, right? And hence, to do that, you would be interacting with cloud at some point, right? So that is essentially how we touch upon cloud computing in general, right? And I have the text in bold and red towards the bottom of my screen. This has become a very common sight on any job role that you come across, right? Irrespective of it being a big company or a startup or even an academic project or anything. Whenever you see terms like building highly scalable solutions, building robust and self-recovering solutions, or just uh, making products that impact a huge audience worldwide, right? Wherever you see those terms, that implicitly means that you will be doing something, you'll be building something that's off the cloud, right? And so it becomes very important to touch upon these topics, have some experience while you are doing your study, or just learn it as a pet project. Cool. So for folks who have worked in tech in the past or know how roles are shaped in the industry today, if you are building tools for the cloud, or if you're just interested in deploying services and applications at a huge scale, there are specific roles for it, right? So all the big tech players out there, even the small and medium-sized companies, they have specialized roles for this. DevOps engineers, SREs, cloud engineers, and the latest one is ML Ops, right, which specifically focuses on delivering ML solutions at a very high scale, especially to a huge audience with minimal latencies, right? So these are all very canonical terms, which are essentially targeting, on making the best use of cloud, and these roles are essentially the subject matter experts with working on the cloud, be it like public cloud like AWS, GCP, Oracle, or be it private cloud, or even just a data center that the company that a tech company in general uses, right? So so now the immediate question is, if you're interested in these roles, I think you definitely need to know the ins and outs of cloud computing, distributed systems, and all the cool products, cutting edge technologies out there. But what if you're interested in a more generic development role, like software engineer or even an ML engineer, right? Do you think cloud computing, knowing cloud computing topics or just having a good stab at that would be useful to you? I think yes. And from what I've noticed in the past 5 years is that the gap between this is closing in, right? There is an overlap on the roles that we are performing. So in the industry today, a software engineer does have to use cloud tools. I think 20 to 30% of their entire time. And the other ways around is true, right? Even DevOps, SREs, and cloud engineers, they are also doing a lot of code development, building the automation scripts and things like that, right? So in today's world, an engineer, a tech engineer out there, right? They are expected to be subject matter experts in a certain thing and yet perform a jack of all trades role in other domains as well, right? So irrespective of you choosing to be a DevOps engineer or a ML Ops engineer or a generic software development engineer, or in the end, an ML engineer of any sort, or even a research scientist, right? I think it will be very crucial and very beneficial for you to at least know how to use cloud tools as a simple user, right? Just having enough knowledge and being a happy path user is also going to benefit you initially and down the line as well, right? And I would like to share a personal experience of myself here, and that is with Terraform. So Terraform is a pretty cutting edge tool provided by a company called HashiCorp. And Terraform essentially revolves around the idea of infrastructure as code, right? So imagine you want to spin up EC2 server on AWS. Ideally, you would go on the AWS portal, do a bunch of clicks, set up configuration for the EC2 instance, and there you have it, right? But that is not a scalable solution, especially at a company, right? So what Terraform in this particular use case is going to say that, hey, write a configuration file of an EC2 instance and build it using Terraform and link it to your AWS account, and I'll handle spinning up the EC2 instance for you. So this sounds like a simple automation, but there is more to it. The beauty of Terraform lies in exactly replicating the state of your infrastructure as code, right? So tomorrow, if someone goes to that server, that EC2 instance, and updates the name, and then you run Terraform again, Terraform is going to notice that the state has changed. The name of the server that you have in the config file is different from what is there actually on AWS. So it's just simply going to force to revert it, right? So it's going to make sure that the state that you have in your config files is reflected on the portal as well. So so that was a quick 2-minute introduction of Terraform. Now, my interaction as a software engineer, who mostly writes Java and Python code, was with Terraform was as a user, right? So we have an infrastructure team that maintains a Terraform repository. So today, in a situation, I had to spin up my application on an EC2 instance. So it was my job as a software engineer to go to the service that our infrastructure or DevOps team maintains. It was my job to write a bunch of config files using obviously examples and templates, and then deploy my application on that EC2 server. So even though I am a software engineer, I had to interact with a cloud computing ecosystem in AWS through Terraform, right? And this, in the end, was a success metric for the work I was doing as well, right? So this is just a personal example of how cloud computing tools has affected me personally. Okay. So, just to give you sorry to throw a bunch of, tool names at you in this presentation, but the tools that you see on the screen right now, right, they have become the current industry-wide standard for managing tools, right? They are battle-worthy, and they have been proven themselves in extremely high scales, right? Down the line, even the Zoom meeting is being powered through some public cloud. It's being running on some Kubernetes pod, which is managed through Helm. Once again, there is Terraform, and then our meetings and logs are going to probably a system like Splunk. And then the Zoom team has, monitoring tools to set up this, right? So, just imagine so much is going on the back end in just provisioning and running the Zoom meeting. And this applies to almost every enterprise service that we have there in the industry today, right? Every company in there is using these tools or a competitive counterpart to make sure that their services have a 99x up runtime, and then they are kind of, they are stable enough. So the main reason behind me showing this list is my request to all the students out there who are planning to apply for tech internships and roles is that check this out. At least check out one of the bullet points, one of all the tools within a sub bullet point, and try to work on them at least once during your tenure, your master's degree or your PhD degree. And I'm pretty sure this will give you a good advantage in terms of applying for internships and jobs. And not only that, right, it's going to teach you the practical uses and the real world use cases that are being used in the industry right now, right? So you can pick what interests you. I'm pretty sure all the projects that you're doing related to systems or networking will touch upon you using GCP or AWS or any public cloud. Right. So I think from my opinion, I think having at least one or two sets of these bullet points on your resume is also going to look really good, and it's going to be something that is eye-catching from a recruiter's perspective, right? And in the end, when you have that introduction meeting with your manager, right, or if you have that a phone screening round, right, you'll have something really cool to talk about and a really good experience to share. And I think this is going to be really beneficial for folks who don't have prior work experience. So yeah. Okay, so you're getting more into details into interviewing, right? These are a bunch of good questions that will frequently show up in your phone screening round, or just while you're talking to a senior or a principal engineer of the team, or even the manager, right? They would want to test your knowledge on just the basic fundamentals of distributed systems and what powers cloud computing in general, right? Out of these 4 questions, right, 2 of them have been asked to me personally in different interviews, that not just one company, right? So I think the last one about Kubernetes is a pretty popular one. It's an exhaustive topic, yet it is very detailed, and you can go into depth on that. So I'm not saying that you should, just mug this up, but just understand the pattern that you're seeing here and try to focus on the concepts it is touching upon. Like the first one, right? It's a simple situation of us differentiating between adding more memory, CPU power versus just having more replicas, right? You can come up with a good instance that you used in your project for that. You can come up with a situation that you faced on a course assignment or on a previous job experience, right? So essentially, my advice to you would be to tackle this strategically in terms of your past experience and being very specific, being very crisp yet specific about what you're talking about. And I would essentially follow the same pattern for such questions that are related to system design and phone screening. Cool. Okay. So going one step further down, right? Going more into the depth of cloud computing and distributed system questions. Here are some more questions that one of these questions can essentially take up your entire interview time slot. You can spend from up to 45 minutes on going into details in one of these situations, right? So this is a gist of all the possibilities that you can come across in a system design interview, or just in on a domain knowledge interview, for example, right? I do not expect to see this in internship interviews. So far, I haven't seen any. I haven't heard of any situation where this was asked, where an internship candidate was asked to build a cloud-based architecture for e-commerce, right? But this is definitely an upcoming, become a more popular round when you're applying for your first job. And I think these sets of questions are very specific to software engineers or SREs or DevOps engineers. I don't expect this to see to be asked to an ML engineer or a research scientist as such. But this slide is for those who are interested and want to pursue cloud computing as their major forte going on. I think now this is an interesting slide, right? What's the best way to learn this? Being good at cloud computing requires hands-on experience in the end, right? You can read about Kubernetes, you can read about AWS as much as you want, but unless you have made those clicks, unless you have gotten your hands dirty, you have spent enough time on the keyboard, have broken things, right? Unless you have done that, you wouldn't be as good at it at any point, right? So I highly recommend one of the 3 courses that we have at CU. I was able to take 2 of them out of these 3. They definitely have a minor overlap, but each of these have touch upon various aspects based on the perspective, right? Distributed systems focuses on the low level perspective. Data center scale computing is like the highest 10,000 feet perspective, and it deals with getting more familiar with all the tools that I showed in the 3rd slide. And big data architecture is a very project focused course. So whatever I would request you to identify the gaps in your resume, and identify where you could learn the most, where the biggest opportunity lies, and then pick that course. I highly recommend at least doing one of these across your graduate degree here. And apart from that, right, the best thing about using these tools is that the companies have open sourced them. We have free online resources and tons of YouTube playlists, so you don't even need to pay for those, and you can just pick it up, do a pet project on the side. And it's the generation of social media. If you spend good enough time on LinkedIn, I would highly suggest following a few people like Alex Shu, Byte Go, and Arslan Ahmed, right? And just look at their posts. Even if you do that as even if you do that as an intermittent thing in your daily routine, it's going to help you a lot. And the focus of these posts and just paying attention to what these experts have to say is just to build the right mindset of building products, of understanding things, applying the right solutions. And finally, Google and multiple companies like Google, Netflix, Amazon, you name it, they have started building their own podcasts that are just to educate the community about it. And just listening to Google's Kubernetes podcast is going to teach you a lot about Kubernetes, and it's going to be, you'll also hear fun tales from seasoned industry experts and people who build Kubernetes by themselves. So yeah, these are some good resources as well. I think I have 3 minutes left, so I think I'll just use those for questions. Any questions? Okay, I think that should be good. I'll just wait maybe 3 more seconds.
Thank you so much, Keval, for joining. This is Bridget. Let me see. Turn my camera.
Thank you.
Hi. Okay, great. I'm Bridget. I'm a grad advisor. Thanks for joining.